Okay, so now we're going to put what we've learned to practice. So we're going to use the examples to name this lovely compound. All right, so remember, rule number one tells us that we have to choose the correct ending. And even going back to think about it, when we're trying to figure out what the parent chain is, we also have to include any multiple bonds. So in this case, I do clearly see that there is a double bond right there. So I know my ending is going to be "ene." Okay, so that's step number one. Rule number one followed. Rule number two says we have to determine the longest carbon chain. So in order to do that, we just have to count. But remember, we have to include the double bond in that. So we know that 1, 2 is going to be included there. 3, 4, 5. This way, I'm only going to have 4, so I know that's not the longest. 1, 2, 3, 4, 5, 6. So I have indicated the longest carbon chain as right there. 6 carbons. Remember, I said that the carbon chain, the longest carbon chain, does not have to be in a straight line. So you kind of see where it kind of curves a little bit. It's always going to be the one that has the most in order, in consecutive order. Okay, so because of that, I have identified my longest looking like this, but I've also included my double bond there. Next, once I've done that, is I have to assign my carbons, or assign a number to my carbons. Now this step you don't necessarily have to write each time, but in the beginning I would recommend it just because it'll help you even with the naming. And when I'm assigning those numbers, those carbons a number, I want to make sure that my double bond in this case has the lowest possible number. So I don't want to start from here, 1, 2, 3, 4, 5, 6. That would make sense. I want to start over here to make sure that it has the lowest number here. Okay? Once I've assigned my numbers, then I have to use my prefixes based on how many carbons I have in the parent chain. Because I have 6 carbons, I know the prefix for 6 is hex. So I know I have a hexene. But with the double bond, I also have to say, where is that double bond? If there were no double bonds, then hexane would have been just fine. But because there is a double bond, I have to say that it's on the first carbon. It starts on the first and ends on the second. So that's actually 1 hexene. Okay? All right. Next step is to identify any breaks or branches. Anything outside of this square is considered a branch or a side chain. All right, so I've got one over here, and now these are connected to one another. It's not 2 separate methyl groups. It's 1, 2. It just contains 2, and then I have one here, and then I have one here as well. Now, the 2 carbon, the prefix for 2 is S, and because it's an alkyl group, the name for that particular branch is going to be ethyl. This is 1 carbon, and this is 1 carbon. Notice the difference. Even though there are 2 carbons here, these are bonded to one another. This is a carbon by itself, and this is a carbon by itself. All right? And so this is meth, and this is meth. So because, again, it's a branch, methyl and methyl. That's how we get there. The next rule is to list them in alphabetical order. And we have to also include the location. Where are they located? So because E comes before M, I know ethyl is going to be listed first, and I have to say where it's located. So in this particular case, ethyl is on the second carbon. So see, it helps you with that. So 2 ethyl, all right, and the methyl, this first methyl is on the 4th carbon, and this methyl is on the 4th carbon. So 4 methyl, 4 methyl. So 2 ethyl, 4 methyl, 4 methyl. Boom, perfect. Now this looks a little complicated, looks a little clunky, it's too long, all of that stuff. And remember, one of the things I said, this is kind of combining rules 7 and 8. We combine them if you have multiple of the same type of branch. And so instead of saying 4 methyl, 4 methyl, I group them together, and now I have dimethyl, because di tells me how many of the methyl group, 2, di, and it's 4, 4 dimethyl right there. So the final name in this particular case is 2-ethyl 4,4-dimethyl 1-hexene. Now the 1-hexene is only referring to the double bond portion, right? And that has to be there. So let's do a couple of practice problems. Sometimes you'll get the structure and you'll have to give me the name. Sometimes you'll just get the name and you'll have to draw that structure. All right, so let's go through. So in this first one, I have 1, 2, 3 carbons, and I have a double bond. So I know my ending is going to be ene, and because I have 3 carbons, the prefix for that is going to be prop. So I would say propene. Now, this one does not require a number because even if the double bond was on this side, it would be the same thing. That would be 1, 2. This case, it's 1, 2. So no need to put the number in this one because there's really only one option for the multiple bond, okay? So that's just propane. If we look at 2-butene, we've kind of done this one a little bit before, but but tells me that there are 4 carbons. Ene tells me that there is a double bond, and it also tells me where the double bond is. It's on the second carbon. It starts on the second carbon and ends on the third carbon. So you should have a structure that looks a little like this. All right, 1, 2, 3, 4, or 1, 2, 3, 4. It really doesn't matter which way you decided to go on that one, but I did have to indicate where it was because the double bond could have easily been on the first carbon. Okay, so that's why the number is necessary here, not necessary here. All right, let's look at 2,4-dimethyl 2-pentene. Now, I wish there was a way that I can kind of start drawing the structure in parts just to kind of see where it is. I always start with my root, all right? So I work here and I say, okay, pent, that means 5 carbons, so I'll put my 5 carbons there. And then there's an ene. I know that there's a double bond there somewhere. Well, it's on the second carbon. So if I were to draw my carbon, I would have 5 carbons, and on the second carbon, I would put a double bond between the second carbon and the third carbon. And then I would locate my second second carbon, and put a methyl group there, and my 4th carbon. So I would have something that looks similar to this, all right? So again, my 1, 2, 3, 4, 5 carbons. On my second carbon, there's a double bond, 1, 2. Starts here and ends on the third carbon. On my second carbon, I have a methyl group. 3, 4th carbon, I have a methyl group. Now, some of you may have said, okay, well, I kind of had it looking a little differently, and that's fine. If you had it looking differently, that's great. Looks the same thing. Now, whether I put my double bond over here or over here, they're the same compound because, again, instead of numbering 1, 2 this way, I numbered 1, 2 that way. All right, so see how the double bond really doesn't change the name because you wanted to put it on this side and I put it on this side. It doesn't matter because my counting is different. Okay, all right, what about this long, lovely looking one? I have 1, 2, 3, 4 carbons. So I know at the very least, well, let me back that up. I know my ending is going to be ine because I have a triple bond here. So that's YNE. And because I have 4, the prefix for 4 is butene. But I need to tell you where the triple bond is because it could either be on this carbon between these two. It could be on between these two. It could have been over here. And so I have to say that it's on 1 butene. That's the name for that one. And again, if there was a triple bond here, then it'd be 2-butene. All right, so in this one, it was 2 because it was between the second and the third carbon. It's 1-butene because it's between the first and the second carbon. All right, so hopefully you guys understand the difference with the numbering. All right, let's look at these last few. All right, so here I know I have a double bond, so that has to be included in my parent chain. So let's see what's my longest. 1, 2, 3, 4, 5. That could possibly be it. 1, 2, 3, 4. Nope, that's going to give me 4. So I know I have 5. And because I have 5, my prefix or my ending, and I have a double bond here, my parent chain is going to be pentene. All right, but again, it's the double bond is on the first carbon, between the first and the second carbon, so it's 1 pentene. But then I also have some alkyl groups here. I have one here, and they're both 1 carbon, so that's meth and methyl, and it's on the 1, 2, 3rd carbon, 3, 3 dimethyl 1 pentene. That's how we arrived at that one. All right, so let's look at this next one here. Okay, so we have a double bond between here and here. So we know 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. Okay, cool. So we have 5 as well on this one. And let's see, with the 5 we have pent, and then we also have an ene, or is it? It's located on the first carbon to the second one. So 1 pentene, all right, perfect. 1, 2, 3, 3, and these are methyls again. 3, 3 dimethyl pentene. So 1 pentene. So it's the same thing. It just looks differently. All right, so again, the parent chain was straight this way. In this case, it kind of curves, so remember that. All right, here's our last one. Ooh, this seems like a big one. All right, we know that this is going to definitely be in the parent chain. So even though it's not on the end, it's still going to be incorporated this way. We're not going to start counting from that one. So 1, 2, 3, 4. I know that's not it. 4, 5, 6, 7. Okay, that's possible. 1, 2, 3, 4, 5, 6, 7. So either way that I decided to go, I know I have 7. So I know hept, and then because there's a triple bond, ine, heptine. But where exactly is that triple bond? 1, 2 on the second carbon. So 2 heptine. Now we have some functional groups. 1, 2, 3, 4, 5, 6, 7. So we know that this is a functional group, and this is a functional group. All right, so with this being one of the functional groups, there are 2 carbons bonded. That's going to be ethyl, and this is only 1 carbon. That's methyl. So on the 1, 2, 3, 4th carbon is methyl. 5 on the 5th carbon is ethyl. But remember, we have to list them in alphabetical order. So that would be 5 ethyl, 4 methyl, 2 heptine. All right, so see how that worked? 1, 2, 3, 4, 5 ethyl, 4 methyl, 2 heptine. All right, so naming is not hard. Well, it's not impossible. It just takes practice. But if you remember the rules, then you'll have no problems. I'm going to give you some practice problems probably next week to do just this. We're going to kind of focus on that before we start talking about those functional groups and before we start talking about some other things. What I want you guys to really focus on today and, of course, tomorrow will be the quiz. Okay? So I will see you guys online. Bye.